Hi everybody, we're here for lesson 6.05 in science, forces and mass. First thing I did was we got busy making a catapult this morning. And so we used some popsicle sticks, some elastics, and the plastic spoon. And then I have 3 different sizes of lovely Play-Doh that my grandchildren played with yesterday. And so I've got the smallest, the medium, and the largest one. One thing to note, in the lesson, it has on page 6 how to build your catapult. If you want to build one at home, it doesn't specifically say to make this little cross with elastics in the middle, but you do need that. All right, so here we go. Open up on page 15, the worksheet called Forces and Mass. Our question is, how is the motion of objects of different masses affected when the same force is applied to them? So how is the motion of objects of different masses affected when the same force is applied to them? The independent variable is the test variable, and that's the mass of the object. And the dependent variable, or the outcome variable, is going to be how far they're able to go, the distance that they travel. Our hypothesis, I'm going to choose the hypothesis. They want it written in an if-then statement. If the mass of an object increases, then the distance it travels will decrease. You could do the inverse if you want as well. So the next section talks about the materials needed for the catapult. We used 7 popsicle sticks. We used some elastics. I don't know how many, whatever. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 of them. And a plastic spoon, and we're using some Play-Doh. All right, the procedure is going to be to place the object on the catapult, to use the same force to pull the catapult down, and then to measure how far they go. So let's see. I've been told by my husband, who practiced this more than I did, to put my finger not on top of the center part of the catapult, because that's where it needs to expand from. So here we go, and my husband's going to find out where it lands. So not where it rolls to, but where it hits the table at. Ready? Go.
36.
36. All right. Now I have to retrieve the Play-Doh. So 36 inches. Was it inches?
Inches.
Okay, 36 inches was the first trial, and here we go again.
34.
34 inches, and here we go again. Hit the chandelier.
42.
We'll call it 42. All right, so that's our first lightest piece of Play-Doh. I don't really have a scale to measure them on, so we're just going to call them light, medium, heavy, or small, medium, large, whatever you want to do. All right, so here's the medium Play-Doh going. First trial, trying to get my fingers off that center piece there. Ooh, that one was about 18, it looked like to me, right there, 18 inches. All right, second one, about 20 inches on that one. And third one, 21 inches. All right, great. And now the big guy. So here we go. Ooh, 11 inches. Didn't go very far. Okay, come on. Here we go, second time. Oh, let's not count that one. I didn't feel like I was ready. Let's try again. Here we go. Oh, that wasn't very good. 9 inches. And last trial, 10 inches. All right. So good job on that. That was kind of fun. I'm sure my grandchildren will have fun throwing things around with that, especially my 3-year-old, almost 4-year-old grandchild. Lulu will really enjoy that. All right, so let's go through the conclusions. So what does the data show, and what can you learn from the data? So the data shows that the objects with less mass traveled the farthest, right? They went pretty far. The objects with the greater mass really didn't go far at all. And so the second question Was my hypothesis correct? It was correct, because my hypothesis was that if the mass of an object increases, then the distance it travels will decrease. So my hypothesis was correct. And so that's shown by the distances that we recorded. And so what can we conclude from the experiment? We'll conclude that objects with more mass travel less with the same force. Objects with more mass travel less with the same force, okay? All right, so the next questions are kind of on you guys, but let's just talk about them a little bit. Now that you've completed the experiment, what new question do you have that you could test? What are you wondering about? Are you wondering about maybe throwing something else? Maybe about a different design of catapult? If you look up on YouTube, there's all kinds of cool videos about how to make different catapults. So if you have those materials, that could be fun. Maybe you're wondering about like actually throwing an object. Like, you know, if you threw a chicken leg, would it go farther than if you threw a whole turkey? Don't try that at home. And then next question. Is science based on observations? Explain how observations are important to your experiment. Science is based on observations, and observations are how you test your experiment, how you prove something. And then the last question, provide one piece of evidence from scientific resources that support your findings. Here I'm just going to say you might want to go to YouTube and look up things like force and mass in motion. There's lots of different videos. If you just provide me the URL and one sentence that you got from it, that would be great. All right, well, that was fun. We'll see you next time. Bye.